Welcome to BSc Statistics students. Now in this lesson I explain one of the problem on the graphical method of processing of two jobs through K missions. Processing of two jobs through the K missions. So I explain one of the problem. So what is the problem? By using graphical method, minimize the time to process the following jobs on the missions shown below. 1, 2, 3, 4, 5. 5 missions are given here. Also calculate the total elapsed time. Of course, we can also calculate ideal times of job 1 and job 2, right? So this is a one kind of variety of problem. This is done through the graphical method. This is done best by using the graphical method, right? So job 1, the sequence of mission. For job 1, sequence of mission processing times are given. What is the sequence of missions? A, B, C, D, E for job 1. The processing times are given here. Job 2, sequence of missions B, C, A, D, E. Remember, this is not as usual different of A, B, C, D, E. Not usual of A, B, C, D, E. This is the sequence is B, C, A, D, E. These are the processing times which are given for job 2 on the for these missions. So now what is the solution of this particular problem? We have to, first of all, we have to prepare the table for job 1 and job 2 like this. What is the table? You see for job 1, sequence of missions, processing time, values represented in the horizontal line of the graph. In the graph, in the horizontal line, what are the values are represented? That is going to be considered first. Just by simple adding the cumulative values, that is cumulative values are required to calculate for processing times. So it is very simple. So sequence of mission you have to write clearly first from the problem. A, B, C, D, E for job 1. And processing times 3, 4, 2, 6, 2. So what are the values which are to be represented there? 3 and 3 plus 4, 7, 7 plus 2, 9, 9 plus 6, 15, 15 plus 2, 17. So this is what you have to calculate first calculation. And then after this, what you have to calculate? What are the values represented in the vertical line? So vertical line, you come to the, take the job 2 and sequence of missions, processing time, values represented in the vertical line of the graph. What is the sequence of jobs? Sequence of missions B, C, A, D, E. And processing times 5, 4, 3, 2, 6. So we have to add 5, it is represented for B, mission B, and 5 plus 4, 4 units, the gap here, 4 units, 9, that is 5 plus 4, 9, it is represented for mission C, etc. Like 9 plus 3, 12, 12 plus 2, 14, 14 plus 6, 20, which are to be represented in the vertical line. Now quickly go to the graph. So these are the values which are to be represented in the graph. You see here, first of all, what I am considering in the graph. So these are the values are represented. This is horizontal line for job 1. Horizontal line for job 1 to represent the job 1. And the vertical line, it is represented for job 2. Job 2, right? And now you see for first of all horizontal line. How to represent this horizontal line? That is values are represented horizontal line. That is for job 1. Already I explained here. This is for job 1. The values represented in the horizontal line 3, 7, 9, 15, 17. So that is what exactly I have considered here. Already I have constructed the graph 3, 7, 9, 15, 17. Constructed the values of the graph in the horizontal line as well as the vertical line. What are to be represented in the vertical line? Which are considered 5, 9, 12, 14 and 20. These are the values, right? So here I have considered already. What are the values I have considered? 5, first of all 5, and then 9, and then 12, then 14, and then 20 I have considered. For which you have to represent what is for which particular mission, that you have to represent. Now, so I am representing now here, this is for mission A. The order of this particular mission which was specified there in the problem, this is of mission B. This is of mission B up to 7. That is 4 hours. Let it be 4 hours of time. 2 hours of time. It is for mission C. This is sequence or an order of the missions. Next mission D. Is it clear? Next mission of mid D. And next mission is E. Okay. Up to here only. 15 to 17, 2 particular hours, 2 hours processing time. So processing times are represented for which mission? A are represented here in the on the horizontal line. A, B, C, D, E. The units also exactly same. It is given. That is the reason why we have added 3 plus 4, 7. So 4 units here, 4 hours here. 3 hours processing time, 2 hours, 6 hours, 2 hours, like that. So similarly, the same thing it is to be represented in on vertical line. So I am representing here the vertical line. It is to be represented. The first one, the processing, that is sequence of missions are first one B. First one B up to the fifth one. And the second one it is C. Is it clear? Second one it is C. Second one is C. And then third mission it is A. Up to 12. A. Clear? It is A. And then it is represented D for 2 particular hours. And then it is represented for the last mission, it is E. In the sequence, it is last mission. Clear? So this is what the last mission. It is going to be represented. Now, what you have to consider? You have to draw the respective horizontal and vertical lines which are to be considered. Right? So now I draw the lines here for 3 to the end. So first of all, I draw the end line. At 20, you draw a line here up to, that is by representing 17 on the x-axis, that is horizontal line. This is the line I am representing up to 17 because the last line is up to 17. Okay. And then I also draw a line from 17. You see here, is it clear? The 17 up to 17, that is one vertical line also I am drawing up to the, which means the end point. Now I show the end point as well. Is it clear? Now this is from 17, the last up to the last point. This is what the last point, end point. Okay, and this is what the starting point. Starting point is O. It is a starting point, the O, right? Now you have to draw the lines for at a very particular value. Now first one 3, you draw one particular vertical line which is connected at the till for the end, that is up to the end. Okay, is it clear? It is drawn at the line. It should be drawn clearly in the line. No, it is not drawn properly. I draw again. Okay, and then You have to draw the next line at 7. Okay, next line at 7. This is what 7, you see, this is what 7. Till the end I am drawing. Till the end, but I am drawing another line. Is it clear? I have drawn a line, and then 9. 9, and then draw a line at 15. Clear? Now it is the 15. You have to draw another line at 15. You see here, 15. I am drawing another line. Okay, I have drawn another line at 15, and then I have to draw line at 17. I already drawn. Okay, and then you have to draw line at horizontal lines, that is at the value 5. You have to draw another particular line. Right, and then you have to draw another line on at 9. Is it clear? At 9. So this is what the 9, the value 9. You have to draw another line here. And then draw a line, another line at 12. This is what 12. Is it clear? This is 12. I am drawing a line. I am drawing another line at 12. Okay, and then draw a line at 14, and so that blocks will be obtained. Okay, so that the blocks will be obtained. So now you see the blocks are obtained here for each and every particular mission, and now you have to find the intersection points, intersection blocks. What are the intersection blocks of the processing times of each and every particular mission? Each and every particular mission. So I draw this line properly. I draw this line properly. Third one, it is not good, and I have drawn the line, right? Now you see, if you represent this, all the lines here are represented here. You see here the blocks are obtained. This is one block, second, third, like these all blocks are obtained. These are called blocks, you see. And then now what you have to see is you have to obtain an intersection parts. That's very important. The next one, after obtaining these blocks, what you have to see, you have to obtain the intersection of this particular each and every particular mission. So you see here, this is mission A, processing time of mission A, intersection points of the processing times of the missions. Mission A. Now again you see, where is the mission A on vertical line? This is horizontal line. This is horizontal line. The vertical line, this is mission A. So this is the block. This block represents, this is intersection part of the mission A. So now I shade this particular block. Shade this particular block so that which is now I write this is what mission A, the intersection part of mission A. Is it clear? This is the block. Okay, I draw line with pen box. For this particular box, I draw a border line. So you see, it is now, it represents very clearly the A. This is what the intersection part of the processing time A. Now next for B, this is B on vertical line. This is the B on horizontal line. This is B on horizontal line. This is the processing time of B on vertical line. That is job 1 and job 2. The intersection part is this. This is the intersection part, right? I'm shading this and drawing, I'm designing some particular fashion, and so that it is going to be represented now. Now I write B. So now I draw one particular design to the, that is I draw one particular border line for entire box or block. So now it is represented, this block is represented, you draw with the help of scale, that is by using the scale, you draw by using scale. So the block, this is intersection part of B, processing time of B, that is mission B. And mission C, this is what mission C in the horizontal line. This is what mission C, processing time of mission C of vertical line. So this is what the box, that is intersection part. The intersection part of mission C, the processing time of mission C, that you have to find out. I have drawn this, and so that this is C. Okay, right? And then again I draw one particular line, that is border line, and to represent clearly and to appear clearly, and use scale. By using scale, you please draw these lines, and so that it will be very clear. And then for D, this is what D on horizontal line, that job 1, and D, here we have D in the vertical line, that is job 2. For job 2, processing time is this for job for mission D and job 2. So therefore the intersection part is this. Clear? Intersection part is this. So now you draw the intersection part, and then I'm just shading it, and so that I'm writing this is what mission D. Mission D. Again I'm drawing this this particular box or block by using pen. Okay, is it clear? And then move to the mission E. This is last one is of mission E. Okay, we have to see the intersection part of mission E. This is of job 1, and job 2 mission E is here. See, this represents mission E. And then now draw the intersection part. This is what the intersection part of mission E. Is it clear now? I'm shading this particular part as well. Okay, I am doing some particular design, and this is what E. Okay, use the scale and then draw these border lines, and so that which will be very clear, appears clearly, right? This is what the intersection part of E, right? Now this is the starting point of this particular entire what you call entire one particular rectangle we have drawn, the border line. This is what the ending point. This is what ending point. This is what starting point. Now what you have to do next, you have to draw one particular diagonal line. Draw one particular diagonal line by making the 45 degrees of angle from starting point to ending point. Clear? For which if the diagonal line meets at a particular box, a particular block, these are all blocks, which meets any particular block, you have to stop the diagonal line, and then you have to draw one vertical line till the end of that particular block. If the diagonal line meets a particular block, then you have to stop, and then you have to draw one vertical line till the end of that particular block. Okay, and then you have to start the diagonal line again by using 45 degrees of angle. and till the end point you have to draw this. Okay, and one more thing, the diagonal line should not pass on these particular that is intersection parts. That is intersection parts are the blocks for the missions A, B, C. These it should not pass. It should not pass on these particular blocks of the respective missions, right? Processing times of the missions. Now I am starting the line, okay, at diagonal line at 45 degrees of angle. Because of these are the, hope you understand clearly, these are 3 units, therefore up to 3 units here. Therefore you can draw the diagonal line because it is a square, 3, 3, so square. So therefore this is 45 degrees angle. So I'm starting the line here and I'm ending here. Why am I ending here? I'm stopping here. Just now I have explained that if it meets, it should not go through these particular box. And these are all called blocks. It meets at a particular block, then you have to stop it. And then you have to draw one vertical line. Okay, so I'm giving a point here. Let it be some, after O, this is, let it be P. This is what P. I'm giving, this is what P. Okay, this is one particular point. I'm drawing one particular green line vertically. Now draw vertically, go vertically till the end of the block up to here, that is from here to here. Draw one particular vertical line. I'm drawing vertical line. Okay, and then I'm stopping here because block ended here. So up till the end of the block you have to draw this particular vertical line. Okay, and then I'm giving, this is the point Q. I'm representing a point Q. This is P, this is O, this is Q. Okay, O, P, Q. And then again start the drawing the diagonal line with 45 degrees angle. So you see this is 45 degrees angle because here 1, 2, 3, 4 units, 1, 2, 3, 4 units. This is 90 degrees, this is 45 degrees, right? Exactly. You can see, you can join the middle points of the these centimeters also. So 40, because 45 degrees is one of the easiest line to draw. You can draw up to here because this is a block which is meeting the block. Okay, here up to here it is meeting the block. If you draw a line until if it meets the block, then you have to stop it. And we should not go through these boxes, blocks. Okay, so now I'm here, you see here, it meets here, this particular block, it meets this, this particular diagonal line meets this particular block, therefore I stopped here. So this is the direction, this is 45 degrees. Again here also this is 45 degrees. Hope you understand. Now I have started this particular line here and then I have ended up to here. I have drawn up to here. It meets some particular intersection point and again I have stopped here because it meets this particular block. Okay, and then you have to draw one particular vertical line. You name this one PQR. Okay, this is called, let it be R. And up to here you draw one particular green line, a vertical line. Clear? A vertical line. And after this up to here, because the block is going to be ended here. Ended here. Up here to here we have drawn this particular line, green line, that is vertical line. And then again we should not go this particular diagonal line in through this particular block because this is a block, it is an intersection part of D. Okay, so therefore till the end of this particular block you have to draw this particular vertical line. This is what the vertical line PQR, let it be S. Again you have to start the diagonal line from S. Okay, from S you have to draw one particular diagonal line. Okay, I'm going through the diagonal line. Okay, now I'm drawing the diagonal line because you know, just now I explained that the meeting center points we can draw the diagonal line. Okay, up to here the diagonal line is going to be continued because it is again a particular block. There is no other way to go outside this entire area. Up to the 20 only you have to go. That is, you have to move, and then you have to stop it. This is what the direction, and this is 45 degrees angle, right? And this is what the last line. Up to this particular line only we can draw. Otherwise we can move here because there is no obstacle. But this is what the end line. In the entire this particular graph, this is the end line. This line is end line. Then we have to move horizontally, because you have to draw this particular line till the end of the last point. This is what the last point. Let it be, let this particular point be after PQ or S. This is, let it be T, and this is, let it be U. Draw another one particular line, horizontal line. Now you have to draw the horizontal line, because up to the point U, the finish, you have to draw the line, draw this particular line, continue this particular line. Okay, so this is what drawing the graph. Okay, by drawing the diagonal line. Now we can identify, this is what the total units are, 20 units. 20 units, which means 20 hours of the processing time. So that is, total elapsed time is 20 hours. That we can easily observe from the graph, because this is a 20. The last point ended at 20. Okay, so therefore this is what the processing time of total elapsed time of completion of this particular work, right? So now I'm writing here the answer of the first question, that is the total elapsed time. It is going to be considered as 20 hours. So now I'll tell you one more point here. What is the point here? If you move horizontally, that is, if you move horizontally, the job 1 is working. If you consider basing on the job 1, then if you move for job 1, if you move vertically, it is an ideal time for the job 1. Similarly, if you move vertically, it is the working time of the job 2. And if you move horizontally, it is an ideal time for the job 2. So therefore now it is easy, you can easily understand. I have drawn green lines. So this is a vertical line, hence it is ideal time for job 1. This is one vertical line, this is one vertical line, and this is one horizontal line. In drawing the diagonal lines, we got 2 vertical lines, 1 horizontal line. Okay, clear? And so therefore horizontal line represents ideal time of job 2. This is the horizontal line. I have shaded with green, okay, or bold line. We can consider the bold line. This is what ideal time for job 2. How many hours? 1 and 2. 2 hours. This is what? 2 hours. 2 hours is ideal time. That in that fashion I write here 2 hours. 2 hours of ideal time for job 2. Vertical lines. Now you observe the vertical line. This is one vertical line which is having the, this is 11, 12, 13, 14. That is 11 to, this is what, 11. Here 1 unit, 2 units, 3 units. That is 3 hours. This is ideal time for job 1. How many hours? 3 hours. 3 hours. Now again one more horizontal vertical line. That is this one. Here to here, P to Q. How much? How many hours here? 1 and 2. That is also ideal time for job 1. It is 2 hours. So what is total ideal time for job 1? It is 3 plus 2. 2 plus 3. That is 5 hours. This is 2. This is 3. Total 5 hours. Now we write in the problem. Right? So in the problem, I am writing ideal times. Ideal time for job 1, it is equivalent to be 2 plus 3, it is equivalent to be 5 hours. And ideal time for job 2 it is equal to 2 hours. That is horizontal line. This represents, this is observed from the horizontal line, that is this is observed from the vertical line. You have to remember that horizontal line, it is going to be it is representing working time of the job 1. And if it is horizontal, if you have represented, simply remember that if you have represented the processing times in job 1 in horizontal line, then any vertical line identified through the diagonal line, drawing the diagonal line, any particular vertical line is observed, it is an idle time for job 1. Similarly, horizontal, the vice versa. Similarly, just horizontal line, any particular horizontal line remains in drawing the diagonal line, which is nothing but idle time for job 2. So this is what you have to observe here. Hope you understand. So from this particular graph, you have to calculate total elapsed time, idle time for job 1, idle time for job 2. Okay, by drawing these rectangulars, this is which are called blocks. You have to identify, you have to construct the blocks, and then you have to draw the diagonal line. This is crucial part. Hope you understand. This is what the graphical method of doing the processing of 2 jobs through the K missions. Thank you very much.